Second preparation for glycerol is from acrolein. Acrolein or acraldehyde. The second preparation of glycerol from acrolein or acraldehyde. So what is the formula of acraldehyde? Hmm? CH2 double bond CH and CHO. This one is called as acrolein. What is the IUPAC name of this one? What is the IUPAC nomenclature? One, two, three. Prop in. At what position in is there? 2 in al. Propane to al. So acraldehyde is going to be reacting with lithium aluminum hydride. Lithium aluminum hydride. Lithium aluminum hydride is a strong oxidizing agent or strong reducing agent? Strong oxidizing agent, right? How it is strong oxidizing agent? What is the meaning of oxidizing agent? It is going to be oxidize others, right? It's going to be oxidize others means this one is going to be get oxygens. For example, take that lithium aluminum hydride. It forms Li plus Al H4 minus. From that LiH4 minus, it is going to be release H minus. Means this one is giving H minus. H minus is giving means that one is it will reduces the others means or oxidizing others. Reducing others means this one is oxidizing agent or reducing agent. Reducing agent. Lithium aluminum hydride is a strong reducing agent which is reduce others. Now if it is reduced by lithium aluminum hydride to the acraldehyde, what happened here? The aldehyde oxidized product is going to be converting into which one? Reduces. It is converting into aldehydes are converting into primary alcohols. Ketones are converting into secondary alcohols. Now, to this formation, this one is what is the name of this one? Allyl alcohol. The allyl alcohol is going to be reacting with 1% alkaline KMnO4. It is going to be reactive with 1% alkaline KMnO4. What is this reagent? This reagent name is called as Bayer's reagent. The reagent name is Bayer's reagent. Whenever if you are reacting with allyl alcohol and Bayer's reagent, it is going to be form Bayer's reagent also it is one of the strong oxidizing agent. It is going to be oxidize the wherever the saturation is going to be present. The primary alcohols are not going to be further oxidation. Sorry, further reduction. So this one is going to be converting into oxidation. Bayer's reagent also we can use for find unsaturation in the molecule. It is also used for find unsaturation unsaturation in the molecule. Bayes reagent can be used to detect the wherever the unsaturation is going to be present or not in the molecule. So like that also we can use that Bayes reagent. Now here in this molecule unsaturation is present. So the Bayes reagent is going to be react with a unsaturated place and it is going to form oxidation CH2. It is going to break this bond and here forms one OH and here also add one OH. It forms CH2OH and it was CHOH and that more is CH2OH. The name of this one is glycerol. That is preparation by acrolein. Next preparation is from propene. Preparation of glycerol from propene. Third one, from propene. This is the method we are going to be generally used for preparing the glycerol by the industries. Now I'm taking that propene CH3 CH double bond CH2. This one only na 1, 2, 3. Prop at first position in is there. One in. Prop in. So propene is going to be reacting with halogen and the presence of 800 Kelvin. So I'm taking the propene and reacting with halogen chlorine with 800 Kelvin. What happened here? It is going to be taking place of elimination. HCl is going to be go out minus HCl. One HCl and one HCl and H is going to be go out. Remaining HCl is going to be attacking the carbon place. CH2 double bond CH and CH2 Cl. So after the formation of this one, I'm going to add the aqueous NaOH or aqueous sodium carbonate Na2CO3. Aqueous Na2CO3 means aqueous means presence of water. Na2CO3 plus H2O. What will happen? It is going to form NaOH plus H2CO3. So indirectly we are adding the base. So it is going to be act as base means it is going to be forms the nucleophilic substitution reaction. So where is the nucleophile will be present? Here it is present. The nucleophile which is coming from the base is going to be replace the Cl minus. The base which is coming, the nucleophile which is coming from that nucleophile base is going to replace the Cl place. So CH2 double bond CH and CH2, the place is occupied by OH. Next, after again, what is the name of this one? Now only we discuss. What is the name of this one? Allyl alcohol. So I'm not taking that base reagent. I'm taking one more reagent to reduce this double bond into a alcohol. I'm taking hypochlorous acid, HOCl. Hypochlorous acid I'm taking. Hypochlorous acid. Now if you are observing this one is oxygen is more electronegative, chlorine is less electronegative, right? HOCl. So oxygen is more electronegative, so negative. This one is positive. Now if we can take this double bond, is going to shift to one side. Means one side is going to form negative charge. One side is going to form positive charge. You can add that C and OH, CH2, CH and CH2, and this one is OH. I'm adding here OH and Cl and already OH is there. So this is going to be formed. Now, again Cl is formed. What we need to take? If you are taking the again any base, it is going to replace the Cl place. Why? Because we need a OH here. CH2 OH and this one is CH2 OH. You can take here aqueous NaOH or any base. You can replace this chlorine place to the OH. CH2 and OH. The name of this one is Glycerol. It's a preparation from propene. This is a general method to prepare that glycerol in industries. Next preparation is fermentation of sugars. From the fermentation of sugars, we can prepare glycerol. Generally, we are going to be use this fermentation preparation for preparing alcohol. We already discussed. We are taking that molasses. What is the molasses? What is the molasses? What was the molasses? It is a mother liquor which is left over the formation of the sugar crystals. What is the waste thing is going to be formed after the formation of the crystals of sugar. So that liquid we can call as mother liquor or molasses. From that molasses we are going to be take yeast bacteria, which if we are reacting with bacteria, it is going to form alcohols. So in that process, the glycerol also going to be formed, but it is going to form only 3%. It is going to be formed nearly 3%. So how can we increase that percentage of yield of glycerol? Means if you are doing that fermentation process in the presence of sodium sulfite, it is going to be nearly increase 25 percentage of yield of glycerol in the fermentation of alcohol. How much percentage is going to be formed the glycerol? 3% only going to be formed. The yield of glycerol is 3% is formed is formed. So how can you increase this percentage? We need to do this fermentation process in the presence of sodium sulfite. However, however, the fermentation process can be takes place in the presence of can be takes place in the presence of sodium sulfite, Na2SO3. Sodium sulfite. If you are doing that in the presence of sodium sulfite, it is going to be increased. The yield, the yield increases to how much percentage? Nearly 25 percentage of the yield is going to be increased of glycerol. So what is the reaction you are going to be taking? If you are taking that mother liquor of sugar and we are doing that hydrolysis, what is the molecule is going to be formed? Glucose, C6H12O6. Glucose is going to be formed. This glucose I am going to do reactivate yeast in the presence of sodium sulfite, Na2CO3. It is going to form glycerol, C3H8O3. Correct only na? Glycerol formula. How many carbons are there in the glycerol? 1, 2, 3 carbons. How many hydrogens? 8. Oxygens are 3. Glycerol will be formed and also acetaldehyde also it's going to be formed plus carbon dioxide. So these three products are going to be formed in the presence of sodium sulfite of glucose fermentation process. The next one is physical properties. Properties of glycerol. Physical properties of glycerol. So physical properties means we are going to be discussing about color, taste, smell, boiling point, solubility. So those are the things are we are going to be discussing physical properties. So what is the color of this glycerol means? It is going to be appears as colorless liquid. It is a colorless liquid and also odorless. Odorless means smellless and also it is going to be nature is viscous in nature. What is the meaning of viscous? Viscous in nature means it is going to be thick and also it is a hygroscopic liquid. It is also hygroscopic liquid. What is the meaning of hygroscopic? Hygro means it is a water molecule. Hydro, which is coming from hydro, water molecule. Scopic means absorbing, absorbs means the liquid which is ready to absorb the water molecule. It is ready to like to what to absorb the water molecule, that is called as hygroscopic liquid. Next one is the taste of this glycerol is a sweet in taste. The one is it was sweet in taste. The taste of glycerol is sweet in taste, and also it one is non-toxic in nature. Non-toxic in nature. So the next one is boiling point. The boiling point of glycerol is high due to the formation of intermolecular hydrogen bond. What is the meaning of hydrogen bond? 563 Kelvin or 67 Kelvin is the boiling point of glycerol. Why it was showing that nearly 190 degrees Celsius. 573 means nearly 197, 193, 193 or 197 degrees Celsius. Why it was showing that one? Due to intermolecular hydrogen bonding. What is the meaning of intermolecular hydrogen bond? In between the two glycerol molecules, there is a formation of hydrogen bond. Due to that formation of attractions, it is going to be required more heat to break that bonds to form vapors. So that's why the boiling point of glycerol is high. The next one is where it can be soluble. Soluble. It can be easily soluble in water, ethanol, and also, but it cannot be soluble in ether. It was not soluble in ether. Why? Because ether is a poor formation of hydrogen bond. But these two, water can be formed four hydrogen bonds, ethanol can form two hydrogen bonds. Due to that formation of hydrogen bonds easily in water and ethanol, it's going to be dissolved very easily in the two liquids. But in the ether, it is not going to be dissolved. Why? Because due to the poor formation of hydrogen bond. So why it is forms that viscous in nature and it is going to be high boiling point means that is the reason due to the formation of intermolecular hydrogen bond. For example, I am taking glycerol, OH, CH, OH, CH2, OH I have taken. 3 I have taken, I am taking one more molecule, H, CH2, CH, OH, one more is CH2. I have taken two glycerol molecules and I'm so if you have taken these two as a adjacent positions, what happened? The formation of bond, the attractions will be formed in between hydrogen and oxygen. The attractions will be formed in between high electronegativity of oxygen, high electronegativity atom of oxygen and hydrogen. That bond we can call as which type of bond? The bond attractions are going to be formed in between hydrogen and high electronegativity atom. The bond is called as hydrogen bond. So basic question. So here also it is going to form one hydrogen bond. It is also forms one hydrogen bond. Whenever it is need to be formed vapors, boiling point means that only now where the vapor pressure of liquid is going to be equal to the atmospheric pressure. Then only it is going to be converting into vapors. Means this one is going to be converting into vapors means this was need to be free nature. Free means there is no bonds need to be attached to this one. So we need to form this one is as vapors means we need to break all the bonds. So we required more heat. So that is the reason to the boiling point of this one is high and also viscous in nature due to the thickness. This is only the reason. It is going to be attract very strongly. If it is attract very strongly means it will be combined and it will be very near to each other. Very near to each other means it will be very thick. So that is the reason for the glycerol is viscous in nature and boiling point is high. The solubility in water and ethanol, but it cannot be in ether. And also it is colorless, odorless, sweet in taste, and non-toxic in nature. Hygroscopic liquid means it is ready to absorb the water molecule due to the formation of four hydrogen bonds in the water. Water can be forms four hydrogen bonds. It can form three hydrogen bonds. So that is the reason. So it is called as hygroscopic liquid. Don't taste if it is sweet in taste. So chemical properties, if you are saying, the first one is reaction with sodium. Reaction with sodium. So if I am taking that glycerol, CH, OH, CH2, OH, and I am reacting with sodium metal at room temperature. I am reacting with room temperature. So what is the role of the sodium? It is having a high reactivity than hydrogen present in the glycerol. Means what will happen? The sodium is can be replaced hydrogen place. So you can replace the hydrogen place. One ONA will forms CH2 OH. We can call this one is monosodium because of only one sodium is present in this molecule. Monosodium glycerate. Monosodium glycerate is going to be called this name. Next one. Why it is for why we are called it 8? Why we are mentioning that 8 here? Glycerate. Negative charge. If it is negative charge will present, we can call as 8. If it is positive charge is present, we can call as unium, IUM ion. It is carbocation, carbonium ion, right? Carbonium ion. If it is Cl minus, carbonate, carbonate ion. So here, what will form here? There is a negative charge is there. That's why we can call as glycerate. Again, I am taking 1 mole of sodium at high temperature. Again, it is going to be replaced one of the hydrogen by sodium. It forms disodium glycerate. CH2ONA and this one is CHOH and it will be CH2ONA. Disodium glycerate. Disodium glycerate is going to be formed if the glycerol is going to be react with the so next property reaction with PCl5, PBr3, PI3. Now I am taking glycerol, CH2OH, CHOH, CH2OH. If it was reacting with three reagents, one is PCl5, PBr3, PI3. I am taking this one is 3 moles. What happened? Alcohol is reacting with any one of the phosphorus halides. It is going to be formed. Which one? Alkyl halides are going to be takes place. Right? This one is CH2, Cl, CH, Cl, CH2, Cl plus POCl3 plus HCl is going to be formed. Here three phosphorus are there. You can write 3 moles. So what about this one? This one also forms alkyl halides. CH2, Br, CH, Br, CH2, Br. Next, H3, PO3 is the byproduct is going to be formed. So what is the final product formed in the PI3? So it is also alkyl halides it forms. So CH2I, CHI and CH2I. This molecule is stable. This molecule, whatever you are written in iodine for reaction, it is stable or not. So this molecule is going to be unstable. Why? Because on the adjacent carbon atoms, on the adjacent carbon atom must be present. There is the presence of big atoms. Big size of atoms are present on the adjacent carbon atoms. Due to that, big size of atoms are going to be hold very difficult, or there is a repulsion is going to be takes place in lone pairs of iodine and iodine. It's going to be go out as I2. Why? Means it is going to be involve this one. This I will be go out. It is I plus is comes here. I minus is comes. I plus and I minus I2 will be formed. So it is an unstable molecule due to the presence of big size atoms present in adjacent carbon atoms. So it will forms here. Here newly one bond is formed. This bond is 52. This side CH2 double bond CH. Next one is CH2 iodine. What is the name of this one? This group is allyl. Allyl iodide. So it is a preparation of. So the next property of glycerol reaction with hydrogen iodide. Reaction with hydrogen iodide. How the hydrogen iodide is going to react with the glycerol? If you are taking that glycerol reacts with or warmed with react or are warmed with small amount of HI. If you are taking the glycerol and if you are reacting with a small amount of HI, it is going to be form. It forms allyl iodide. Allyl iodide is going to be formed if you are taking the glycerol, if you are reacting with or warmed with a small amount of hydrogen iodide. How it is going to be formed? CH2OH and CHOH, CH2 OH I have taken. Means this one is glycerol. I am reacting with HI. I am taking 3 moles. If I am taking 3 moles means what happened? It is an acid. HA is an acid. Acid means it is going to be releases that H plus ion. That H plus ion is going to be attack on OH. So lone pairs of oxygen is going to be takes that H place. It forms water molecule here, right? Water molecule is going to form with the positive charge. So on the oxygen is positive charge is going to form means that is highly unstable. So it is going to take its electrons back means there is loss of water molecule. So after the loss of water molecule, what happened in this carbon? Positive charge is going to be formed, right? That positive charge is going to be affected by I minus. So the I minus is going to be directly add on the CH2, CH, CH2. Why? Because we are taking 3 moles. I'm writing directly I'm writing CH2 iodine, CH iode, CH2 iodine. Again, same rule. On the adjacent carbon atoms, there is the presence of big size of atoms. So we can remove that I. Allyl iodine is going to be allyl iodide is going to be formed. What happened if you are taking that allyl iodide and reacting with the HI? What happened? This formed allyl iodide and reacting with HI. I am writing reaction here. See, CH2, CH2, double bond, CH and CH2, iodine I am taken. I am reacting with HI. What happened? It will form H plus as well as I minus. Now see, the double bond is going to be which side? The double bond is going to be move to upside. It forms CH2. Upside is going to be formed negative charge. Means hydrogen is going to be attack on CH2. So it will form CH3. Then on the middle carbon it's going to form positive charge. Positive charge is formed means I minus is going to be takes place and this one is CH. What we can call this one? Isopropyl. Sorry, here CH2I. CH2I. Again, what you are getting? Two iodines on two adjacent position of carbons. Again unstable. Again the elimination reaction of I2. CH3, CH double bond, CH2. Now I am reacting again HI. Where the iodine is going to be reactor? This double bond is going to be shift to this side. Why it is not going to shift to middle? Why it is not going to shift to this carbon? Why it is going to be shifting to this carbon? If you are, it is double bond is going to be shifted to middle carbon. Middle carbon is going to be get negative charge. Negative charge. Negative charge is going to be balanced by electron releasing groups or electron withdrawing groups. Electron withdrawing groups. So, but here CH3 is present. CH3 is releasing group. That side is unstable. That is going to be. That is the reason the double bond is going to be shifted to downwards. Now what happened? The H plus is going to be attack on CH2 minus. So it will forms CH3. On the middle carbon is going to form positive charge. It's going to be attacked by iodine. What is the name of this one? Isopropyl. Isopropyl iodide. Isopropyl iodide. So remaining chemical properties we'll discuss tomorrow. So these are the some of the chemical properties and physical properties and preparations of glycerol.